Okay, we have seen an accelerating cavity, but acceleration is not everything. What happens after the acceleration to the speed of light?
What to say, it was said at the LINAC 4 you are half of the speed of the light, but after the SPS, PS and SPS, you are at the speed of the light. When you are entering in LHC, you are already at 99.99% of the speed of light. It's a slight increase of the light, but it's not so much the speed. We are putting energy in the particle. All the goal of an accelerator at the end is to put energy in particle, to smash them, and to transfer this energy in mass, and to look at in the big detector what are these new particles created by this smash of protons.
Okay, quite clear. Let's now see what happened to beams once they are in the LHC at the speed of light. And why do physicists need these accelerated particles? What they do with them? And let me introduce Freya Blackman, particle physicist and member of the CMS collaboration. Hi, welcome, and nice to see you here. So it's your moment now, because we have this tough question. So why do physicists need to accelerate this particle at the speed of light, and what they do with them?
Okay, so there is multiple aspects to this. So for one thing, there is an equation that most people might have known of. It's a very, very famous equation by Einstein, E equals mc squared. And what that means for us is that we can use the energy of the particles in the Large Hadron Collider to make other particles. And some of these particles are very rare. And this is why it's always important that we are also upgrading the Large Hadron Collider and all the pre-accelerators, which is what you saw before, because we want a lot of collisions. Most of the things that we are interested in, for example, the Higgs particle, is very, very rare. The LHC beams, they collide like every 40 million times per second, so it's every 25 nanoseconds. But most of those collisions make particles we already know and have studied before. So here you see some actual collisions. This is a collision where we think a Higgs particle was produced. And what you see there is that actually all the different particles that are produced, we try to record with our detectors that are put around the collision point. And this is what you will see later when we go to some of the experiments, because these are very, very large 3D digital cameras that take photos of these collisions. Now, the interesting thing is that every collision is different. In every collision, different particles are made. And the rare ones, the ones that we are interested in, they only happen extremely rarely, which is why it's so important that we collide enough, 40 million times per second.
Wow, very, very interesting and well explained. Now, let's see where Paola is right now. I guess she's arrived at CMS.
Wow, 100-meter deep pit. This is real exploration inside CERN accelerator complex. We are at CMS, the compact muon solenoid, 100 meters below ground. Let's go.
Okay,
so exploration starting in the lift.
We'll see. Okay, just, everybody, just move towards the back of the elevator, please. CMS.
This is the bypass tunnel. And here we are, 97 meters below ground to be precise. This is the fabulous compact muon solenoid. It's compact compared to the other big detector around the LHC, the giant Atlas, but it's still very, very huge. It's 14 meters high. And this is the birthplace of the Higgs boson. Actually, the particles, the beams coming from the LHC collider just collide in the middle, right there, in the middle of the detector, around 4 points. This is one of the 4 points. And then from the energy of the collisions, physicists can photograph, basically, take images, very special ones, with these huge detectors of the particles and the new physics phenomena that emerge from the energy of these collisions. It's quite exceptional to be here right now. It's fantastic. You're going to ask questions to the guests, physicists on stage. I can only share for now with you the excitement of being in the birthplace of the Higgs boson and many more particles and many future discoveries.